Well, folks, another one of the gentlemen from the trucking and farming thing. We've got 3 of his to do. The first 3 have all been repairs, and usually most of his sets are just to retune and test. So let's see whether this can be an easy 40-minute retune and test and not an actual repair. So we've also got a Binatone 5-star to do of his in a box, no doubt immaculate, and we've also got a Binatone Route 66, the late version. Now I own, because I've been given to sell on as a donation, we've been given an early version Route 66, and it might be sensible to do Mr. Trucking and Farming's Mark II, which is much easier to align, and then straight after the next job do my Route 66 Mark I, which uses a PLL02A phase lock loop chip intended for the American market, and then they've got to do lots of conversion to make it. This was designed like this. It's just that the dedicated UK phase lock loop chips weren't available at that point, and that's why they did it that way. It's all approved now. I say conversion, it doesn't mean it was converted from something else. It never was anything else. But there you go. It would be interesting to kind of see the two straight after each other. They're going to perform the same. It's just the way the phase lock loop's done. So Amstrad 900. Alan Sugar says he lost money on every one of these. They were there as a loss leader, saying, well, these were £79.99, but for £10 more you can have PA, Roger Bleep and Channel 9 switch, but these didn't cost him £10 less. So there you go. Now, these would have shipped with an Action Man mic. No, they wouldn't. This is a later version. So it's that, what you'd call a Mustang type mic. It's got the bracket, it's got the power lead. We'll put the mic back in there. We won't, because it's a funny kind of box arrangement, this. You kind of take the accessories out. So there's no problems with fakeries. These are always genuine. Nobody faked the lower version. So you can always be rest assured it's the real thing. Now, it's the early type of connector. And he's actually got the one for that. What we're going to do, Mr. Chippie, we've got a friend of ours, Gareth in Leeds, who is doing some 3D printing. He's designed a plug which doesn't have the little tabs which lock it in, but conversely they don't snap off, which they do on the real thing. These were discontinued. These were unavailable by December 1981, so this is the problem. But he's done this, and for the first time in the last few months we've been able to offer a lead which fits these. So I'm going to go and get one of those from stock. I think we better get I ought to get a bundle of these dusters, and we'll have a different colour every day. I'll go and get a power lead, and we'll do all the tests on our standard Cybernet test mic. These are the only thing Amstrad about these are the name on the front. It is a Cybernet 002F chassis. Okay, here we are plugged in. I've got it on 9 volts just as a start, because I don't know when it was last switched on. We'll now change that to 13.8. And now there we are. Plugging our mic. Obviously we're not going to be able to test PA because it hasn't got it. What's the guessing on this? 2.7 watts on transmit. Let's switch picture in picture on. There we go. Go to the 3 watt scale of the test set. 2.85 watts. Channel 40 not working. It means the VCO's out. Out of interest, let's see what channel it comes in on. Let's try 35. No. Let's try 30. Yes. Let's try 31. Yes. Up to 32. Channels above 32, no TX. Channel 1, 3.75. Back to channel 20. It's obviously the VCO's out on this, which is why you need to check them every time. Is this another return? Or has it just gone like this? Low power, 210 milliwatts. It's non-adjustable on these, but it will change as I sort out the main power. Transmit power consumption. Just put that back into full power. 1.253 amps for that. Something's out of kilter, isn't it? It's 2.75 as well, not 3.75. So when we key up, what does the meter say? It says all the bars. So we put down FSD for full scale deflection. We'll have a look at deviation on this test set. See where we are. 3.5. So it certainly had the screwdriver expert in it. Frequency. Let's go to the frequency counter. 2779104 is fair enough. 2779104, and if we don't get it better than that, well, that doesn't matter. It's well within. 2779125 is where it's supposed to be. So, it doesn't have a meter lamp, it doesn't have PA, and the sockets work. Right, we'll go over to receive. So I'll plug in my test gear. We're going to have to get an earth from somewhere. Let's try the outer shell of the plug. Yep. Right. So we need to put this frequency into the signal generator. So 2779104. So we take it as off frequency as it is. So it's an accurate reading. That'll do, 109. Right, let's look at what we've got. Want a decent amount of volume for the AGC to work. It sounds a bit strangled. Sensitivity is 0.41. mean, that's in spec. 0.33, and if it does 20, it does 0.66. Squelch to full, so I like the squelch to be 100 microvolts at maximum, so an S9 equivalent. We'll put that up. Full squelch is in fact, full squelch is only 6.5 microvolts. A minimum squelch straight in at 0.3. S meter should be S9 100 microvolts, and it is, but it won't be when we've retuned it. The switches work. Let's just see about the potentiometers. The potentiometers work. Yep. Right, we'll get it opened up and see whether it can be unscrewdrivered, because that's what it looks like it's got. Right. So usual thing, if we can't get 3.6 watts out of it, we change the ballast resistor. Oh, come on off. I think we're going to end up taking that off. Taking that off. I'll put that, yeah, it's the 2.5 watt type resistors on this. I think some of the early samples were overpower, and they had to do this at Amstrad in the UK to make them legal, but they dropped it well under. Right, so we've got a problem with this. It's not transmitting on channels over 32, so we go to channel 1, we set the VCO. So I want crocodile clip for an earth. May as well put that to a coil can. It's the far side of capacitor 6. I've already forgotten what it's supposed to be. I'll see if we've got a service manual here. Right, that's the relevant page. While we're at it, I've printed this specification on this side. What's it say? It doesn't say, does it? I mean, it says squelch threshold sensitivity right down to 0.15 of a microvolt, which is possible. It doesn't say what the sensitivity is supposed to be. Anyway, they're usually under 0.5, and what's this? It is anyway. Right, so what are we doing? What voltage are we looking for? VCO adjustment, capacitor 9 it is, and it's It's channel 40. No wonder I'm confused. So it's done on channel 40, which is interesting because of course it won't work because it doesn't transmit on there. So we're looking between we're looking at like 4.5 volts on there, and you start with it on transmit. What am I telling you? No, you start on receive. I'm going to go out of this room and start again. The check is on channel 40. It's done on channel 1 like I was in the first place. We start in receive and we're looking for 2 volts. So capacitor 9 is there and it's 2 volts. But we're going to reduce that a fraction. It doesn't need it, but we will. I'm not going that low. Okay, so that's lowered down. Now in transmit, and this is where it's not going to be working at the moment. Where's the mic gone? We should have the same. And it's high. It's 3.5. So we'll do the trimmer capacitor. Okay, so now we've got 2.2 on transmit, we've got 2 on receive. So our checksum's on channel 40, and we should have somewhere around about 4 volts, which we have. That's definitely in lock. And on transmit, let's just put the test set back into transmit mode. We should have somewhere around about 4 volts, and we have, and it's now transmitting. So the trimmer capacitor was the one that was out. That was predictable. So that's it's actually fixed. So now we'll go over to channel 20. So it's 2 plus 2 now. And it was 2.15 plus 3.6. And that's where we were. That was where it was wrong. We'll see if it'll come up on frequency. Some will, some won't. Now they're 40 years old, the crystals have sometimes gone beyond. It doesn't matter because they'll probably take another 40 years to age beyond usefulness. It's gone. 2779125. So that's another thing done. So we'll do the transmitter, get it balanced nicely, and see whether we can actually get 3.6 or more watts out of it. Now I've lost the trimming tool. The 3 watt scale, so full scale deflection's 3 watts. Because we're only doing 2.8. So we're on channel 20. We'll start with the first transmitter. We're looking at centre of the peak. That was spot on already. That not quite. that not quite. So we're now at 2.9 watts for what that's worth. That was at peak. I won't fill that in yet, and the one we do the power adjustment on is there. I don't think this one's going to go. It's just doing 3 watts. Yeah, we can't get any more out of it. So we need to change the ballast resistor on this one and not drop the trimming tool on the floor. So here's the idea. By changing the ballast resistor to one capable of 6 watts instead of one capable of 2.5 or 3 watts, we've got a fighting chance of getting a bit nearer to a 4 watt output. So I use these W22 star vitreous enamel ones. I remember ordering these during COVID and it was a 9-month wait. Yeah, that's what I want. We're going down slightly. It's supposed to be 3.3 ohms. We are going to go down to 2.8, so it gets a double fighting chance. I've said a million times before, if you ever see this removed or linked out, you must put one back in, because the power it develops is mainly on aircraft band. You put a cheap meter on and you go, oh look, this radio is doing 7 watts, but when you actually look at it, it's doing 2 watts on 27 megs and 4 watts on aircraft band. So that's what the result. I've shown it on here many times anyway. Don't need to go on and on and on about it, but not everybody's seen all the videos, so I will mention it from time to time. And it's actually that triggered me into starting this channel. I thought, this is absolute BS. The output transistor is a very expensive device, you know, like 16 quid. Yeah, AliExpress is full of fake ones. Right, turn the power off, get this out. I mean, that output transistor looks like it's been changed. Whilst we've got the bottom off, I'll check these screws are tight. So we'll take that piece of sister flex off that, put it on the new one. I'd also rather this stand off the board a little bit more than they do at the factory, because you've got this capacitor here. All it's going to do is shorten the life of the capacitor. Let's see whether we can keep it in position. Solder it up. Right. For some reason there's been soldering, as I say, around the output transistor. So we'll cover my job and that job at the same time. And neaten it up somewhat. That shouldn't take long to dry. So we'll move. What we'll do, move over to the receiver whilst that dries. I'm going to put the lid on because it can affect the tuning. I remember Pi actually issuing, as in two-way radio, before it was Philips, before it was Simoco. I'm going to put one screw in to stop this sliding away. They actually issued dummy bottoms for some of the sets, so you could tune them without this capacitive effect. Alright, switch on. Let's look at receive. So now we're on frequency, need to reset the signal generator to be spot on frequency. And there we are, spot on frequency. So we haven't got the nicest of tracers there. Just do the detector. Very slightly out. I'm going to do the IF first, in view of that. That's alright. That's alright. Micro, tiny bit not right. Oh well, it's obviously. Put it back. Just check that again. Definitely peak. Well, I think that's the best we're getting today. Let's do the front end. We'll go to the SINAD meter. Drop the signal down so we're not overloading the front end. That was spot on. That was spot on. That was spot on. That's how it is. Right, let's get a new reading. And because I've done the detector, it could be worse. So that's our 12 position. Oh well, you wouldn't believe that. It is better. What? It's 0.29. I didn't see that happening. You know, nothing seemed to be changing that dramatically. 0.25. we've lost a bit here, 0.72. Right, squelch. Oh no, we'll do the meter. Turn the volume down a fraction. So that is showing S9 quite correctly at 100 microvolts. Let's just put up the signal generator. I'll just put the attenuator on. So it's 100 microvolts. If I increase it, I want plus 30 to light, and it does. So I don't. That needs no intervention. It's spot on. It's the preset there for the meter sensitivity. No, it's not. It's the preset there. That's the squelch, and that's what we are going to do. So I'm going to put squelch to full. I want it to come in at that. So we'll drop the signal down and turn this preset until the squelch comes in. I'm now at 30 microvolts, turn it again. Go to 100 microvolts and it's opening, that's what I want. So I did that carefully in stages. Now at the opposite end, turn it down to minimum and set threshold on the radio. Nothing coming in. So we've now got to back that off a fraction into there. So you can't kind of quite have the maximum how I want it. So we'll do that again. We're going to put squelch to full, see where it comes in as maximum. Well, it's still 100 microvolts, so that's how I want it. Once again, we'll turn the squelch down. It is hissing, because some of these cannot hiss until you put an aerial in. I've explained all this before. The squelch is built into the LA1230 FM subsystem chip, which was actually designed for hi-fi stereo systems. So it's the interstage muting, and it's a bit different to one dedicated for communications radios, like the Motorola MC3357, which is often used. So, squelch set, signal generator back on, we're straight in at 0.3. So that's working very nicely, thank you very much. So we've got that to 100 microvolts, we've got that still at 0.3 microvolts. So it was very wishy-washy, wasn't it, at 6.5. That's still correct with no intervention. So we're now going to just sort this ballast resistor. Right, going to transmit, show the main meter, and let's see whether we can get above 3.6 watts. Well, we're banging beyond the 3. So it's now doing 5. Right, so we need to still tune it to maximum here. It is. Check it's at maximum here. It is, and drop it here to 4, and let's see where we are on the other channels. Channel 40, not quite, it's 3.8. I want it to be better than that, so we're going to just have to manipulate this a bit. So it's not that which is dropping it. So is it this one? No, it's not. Is it this one? No. Is it this one? Have we got a coil that's stretched? Or in the wrong position? That, right, I'm going to start again because I've upset the tuning. So channel, you see this all has to be manipulated right. It's at 0.2 the guidelines are, you don't want it to be more than 0.1. So if it out, so by that I mean if we've got 4 watts on channel 20, we don't want it to be worse than 3.9 on channel 40 or channel 1. And this was 3.8, which is out of the tolerance which you're expected to be working to. So let's just retune this all over again. So that's centre of peak, centre of peak, centre of peak, centre of peak. We need to drop that to 4. Right, channel 40, 3.8, channel 1, 4.2. It only needs one of these to be in the wrong position. Right, let's try that again. Channel 20. So we'll bring that to 4 watts. Okay, channel 40. 3.9 watts. Channel 1, 4.01. It's going to have to be like that. I could go backwards and forwards, but it's within what I'd expect now. What did I say? 4.1, yeah. Right, low power. I'll tell you what, we'll do the meter next, because that's going to be a bit over generous. So I wanted to just light the 5th one. And on low power, I'd expect it to light 1, which it does. So now we're on low power. Let's see what the low power is. Well, it's 390 milliwatts. Well, that's worked itself out nicely. Wow, that's pleasing. And finally, current consumption, 1.256 amps. 1.256 amps. It was 1.253 for 2.85 watts output. So we've gained a watt and we're drawing 0.003 more. So absolutely unbelievable, isn't it? Just goes to show how it's tuned correctly. Draws less current, better internal SWR. That brings us now to the final thing, which is the deviation. So we'll plug it into the deviation meter on the test set behind me. We were getting 3.5 off the marker. This test set isn't on, so I'm going to have to come back in 20 minutes when it's come up to a suitable temperature. We had a Schlumberger test instrument at Nottingham Radio, and its best accuracy was after 6 months of being on.